everyone, welcome back to my channel. I hope you guys are doing well and learning new things every day. So welcome to the Python series. Today, we are going to convert a flat file with no headers into a Python data frame. So first of all, what is a data frame? It is like a set of rows and columns in Python. So for instance, you see this Excel file here. This is nothing but a set of rows and columns, right? These are the columns and these are the rows right here. So if we take this entire Excel sheet to Python, it becomes a Python data frame. And we have this flat file in which we have around 3000 data points, all separated by spaces. So when I say separated, it also refers to delimiters. Delimiters can be of any type. It could be a space, it could be a semicolon, it could be a comma, it could be a tab separated file. There are a lot of types of delimiters, and you should know how to import these kind of files into your Python. So just practice on that a bit. Right now, my file is without a header. There's absolutely no header. It's just all data values. And we have to import this headerless file into Python and create a data frame out of this. So let's get started. Now, I am using the Jupyter Notebook IDE. You can use anything. You can use Google Colab, whatever you're comfortable with, you can go ahead with that. And I'll be using the Pandas package with this. Pandas is a very commonly used package for data analysis, data manipulations, and all. So we can get started with importing Pandas. I'll import Pandas as PD here. Now we need to import the data file. I'll call it data. And I'll use the pt.read_csv functionality for that. Now I'll give the file name. There are many more functionalities to be used with this, like delimiters and headers when we are importing a flat file. But I want to show you without that. So let's run this. So this gets imported exactly like how my flat file was. You can refer to this. And so we need to use a delimiter here because our file is delimited by space and it's a flat file. So using delimiters is important here. So if I just give the delimiter option, then what happens? If you observe, the data values have become headers because our file did not have any headers. If you look here, there are no column names which we have, right? So the import function assumes that the first row of the data is a header. And if we do not give any header equal to none option, the data values become the headers. We don't want that. So what we will do is we will give the header equal to none. So after we do this, then our data values have been imported correctly. Now, as you can see, the Python indexes run from 0 onwards. So the first index is a 0. We should also know how to access data here. So if I want to access 2725, how do I tell Python that I want to retrieve this value? We need to use indexing for that. And .ilog is a functionality used for indexing. Let's see how that works. So first of all, we need to give the data frame name. Our data frame is currently called data. So I'll use that. Followed by ilog. This is nothing but a locator of your data value. And then followed by row index and column index. So rows, comma, columns. So here, if I want to access 2725, what is the row index of that? 0. And what is the column index of that? 5. So let me try doing that. So 0, 5. So I got 2725. Right? This is how we access data in a data frame using the ilog functionality here. Let's access some other value now. Let's access 2024. Now, what is the row index of that? 0. And what is the column index? 9. So 0, 9. So we got 2024. Like this, you can access any data value. This is for accessing a single point of data. But we also many times have to access a range of values. So when I say range, it's multiple values at once. So if I want to access 1706 up till 2543, how do I access that? Let's see. So first of all, we need to write the data frame name. So data.ilog and then rows, comma, columns. So this entire data of 1706 up till 2543 all lie in row number 0. So we can use 0 here. Comma, columns. Now, we don't have a single column index for this. Like here, we were using 5 and 9 as single column indexes because we were accessing a single data point. But this time it's going to be a range. We are accessing this entire range of 1706 up till 2543. So we are going to be using a range of indexes. Whenever we are using a range, we always need to give start and end to that. So we are starting from what index? 0. And we are going up till what index? Ideally 2, right? Because 2543's index is 2. So let me define that here. So as we discussed, my starting index is what? 0. So let me write that here. And what is my end index? I want to access up till 2543. So ideally, I should be writing 2 here. Let me show you what happens if I write 2. Let's run this. So do you see what happened? We got 1706 and we got 30. 1706 and 30. We did not get 2543. Can you think of why it happened? Why did we not get 2543 despite giving 2 as my end index? This is because whenever we are accessing a range of indexes, the end value is always excluded. So if we provide 2, data will be taken till 1. It always gets reduced by 1. So whatever number we provide in the end index will be reduced by 1. If we provide 9, data will be taken till 8. If we provide 6, data will be taken till 5. So we need to always add 1 to our end index. So here, because we want to access data till 2543, we need to add 1 to our end index. So our end index ideally is 2. So instead of 2, we will write 3. Let's do that. And so we got 1706, 30, and 2543 all together. This is what we were looking for, correct? Let's try one more example. Let's access this range now. So 2725 up till 2024. What is our starting index of this? 5. And what is our end index for this? 9. But if we give 9, we will not get till 9. We will get only till 8 because the end index will get reduced by 1. So if we want to access 2725 up till 2024, what should we do? We should add 1 to our end index. So if it is 9, we should write 10. Let's do that. And let's run this. So we got the entire range of values from 2725 up till 2024, as you can see here. Let's just try one more example so that we are very clear as to how this range happens. Let's access 2543 up to 1798. So for this, what is the starting index? 2. So I'll write 2. And what is my end index here? 4. But what do we do with the end index? We always add 1 to that, right? So instead of 4, what will I write? 5. Let's run this. So we got 2543 up till 1798, as you can see here. So I hope you are clear as to how this range of indexing happens. Now, since the data frame only has one row, which is index number 0, you can either write 0 or you can even write colon here. Colon means you want to access all the rows. So because we have only one row, we write colon or we write 0, doesn't matter. I just want to show you with that also what happens. So it's just a different way of representation here. Earlier you were getting data vertically, now you are getting the data horizontally. I think this is much more easier to read. We can just exactly match it with our data frame as well. So we will keep this, right? So I hope that is clear. Now, what are we trying to do with this indexing and with this data frame? So currently my data got imported in a single row. As you can see, I have 3000 columns and I have only one row. But I am looking to create 10 columns out of this and the rest of the data should be distributed in rows. So this is my desired output, right? 10 columns and the rest of the data goes in rows. Since we have 3000 data points, we will have 300 rows for that, right? 10 columns into 300 rows. So 3000 data points of that. So what we are going to do is we will take 10 values at once and call it row number 1. And then we will take the next 10 values and call it row number 2. So like this, we will keep on doing for row number 3, We will take the next 10 values and call it row number 3. And then we will take the next 10 values of that and call it row number 4. Like this, we will keep on doing this till row number 300. This is a manual way of doing it. We will be doing it via a function, but we will first take a manual approach and see what is happening. I would suggest, if you're not an expert in writing functions yet, or if you do not have a knowledge of functions, write your steps manually. It gives us a lot of clarity as to what is happening, and it helps us write the function in a more efficient manner. So do that. We are going to start creating these rows manually first, and then we will move on to the functions. So let's do that. Let's create this first row manually. Now, for the first row, which are the columns we are trying to access? Column number 0 to column number 9, correct? This entire data is in the first row again. So let's try to access that. So let's copy all these steps here. Okay. Now we are going to access the same number of rows, which is all the rows here. We just need to make a change in the start and the end index. For our first row, what is the start index? We are accessing this entire range of data. And so a starting index is 0, correct? So we will give 0 in the start index. And then what is our end index? We are accessing data right up till 2024, correct? So what do we do with the end index? We always add 1 to that. So what will be the value we will give in the end index? 9 plus 1, 10. Let's create the first row and we'll call it R1. So we got a first row, 1706 up till 2024. Let's match it with the output as well. So 1706 right up till 2024. So my first row is created nicely. And this is a manual step. We will be using all of these steps in our function as well. Now we have our first row done. Now we had our first row from this value till 2024. Where will our second row start from? Right from the next value after 2024. So our starting index for row 2 is 10, right? It starts from 718 and goes right up till 1689, correct? So our S is 10 and our N is effectively 19. But what do we do with the end index? We always add 1. So it will be 19 plus 1, 20. And we can access using the .ilog functionality. So again, we will access all the rows and then start to end for the column indexes. Let's call R2. So my rows are from 718 to 1689, right? This is exactly what was in my output as well, 718 to 1689. So I'm happy with this output. Now let's try to append both the rows. So we will use the .append functionality. And we will take row 1 as the base and append row 2 to that. So R1 is equal to R1 dot append R2. Simple as that. Let's call this. So was this the kind of appending we were looking at? Like row 1 to be placed in indexes number 0 to 9 like this. And then we have all the missing values for row number 2 for these indexes. And then row number 2 appears from 10 to 19. Is this the kind of appending we were expecting? Or were we expecting a data frame like this? I think I was expecting a data frame like that, wherein 718 would be placed below 1706 here and 2700 will be placed below 30 here. So can you think of the reason why this happened? So this happened because of the different headers we have for both the rows. Now for row 1, we have headers running from 0 to 9. But for row number 2, the headers are running from 10 to 19. So when Pandas was appending the rows for 0 to 9 here, it did not find any values for row number 2 because row number 2 did not have any values from 0 to 9. So that's why it assigned missing values for that. And for indexes 10 to 19, it did not find any values for row number 1 because row number 1 did not have any values for 10 to 19 indexes, right? It only had values from 0 to 9. And that's why these values were assigned as missing here. So to resolve this problem, what we can do is we can make the headers same for both the rows. We can take R1 as the base row and change the column names for row 2. Let's do that. We will use the dot columns functionality for this. So R2 dot columns is equal to R1 dot columns. Right here, we are assigning the column names of R2 as same as R1. Let's run this. So the column headers of row 2 have also become the same as column 1. Both row 1 and row 2 have the same column headers as 0 to 9 here. Look at this. R1 has headers from 0 to 9, same as R2 as well, 0 to 9. Now let's append both the rows. Look at this. So 718 is placed below 1706. Same for 2700 as well. This is placed below 30. And it looks exactly the way it was looking in my output as well. So let's create row number 3 now. The row number 3 will start from one value after the row number 2 ended. My row number 2 ended at 1689, right? R2 ended at 1689. The index of that was 19. Correct? So my row number 3 will start from what index? 20. Simple as that. So let me just write that down here, 20. And where will it end? So because we are dividing our data into sections of 10 columns each, so my row 3 will go right from 2546 up till 2780, having the index 29, right? And what do we do with the end index? We always add 1 to that. So what will be the end index that we will write? 29 plus 1, 30, right? So we will write it as E equal to 30. And we can copy all of these steps of row number 2 here and use it for row number 3 as well. We can replace R2 with R3 because we are creating that. Also, if you observe one thing, when we went from R1 to R2, what were we doing with the start and the end index? So R1's start was 0, R2 start was 10. So we in effect incremented the start by 10. What did we do with the end index? R1's end was 10 and R2's end was 20. So again, this was an increment, right? 10 to 20 is an increment. 0 to 10 again is an increment. So for every row, we are incrementing both start and end indexes by 10. So instead of hard coding it for row number 3, what can we do is we can make it dynamic. So we can just increment the start and the end. Simple as that. So let's do that here and see what the result is. And let's run this. Rest of the things remain the same. And let's run this. So my R3's output is 2546 to 2780. And we made the codes dynamic. Right? Let's match it with our output as well. So my R3 is 2546 right up till 2780. Look at this. 2546 to 2780. The result is accurate. So now what we need to do is we need to append the rows. And let's run this. It looks exactly the way it was looking in my output as well. So till now, we have created 3 rows out of this. We are intending at creating 300 rows. You saw all these manual steps and we created each row manually. But we did it for how many rows? Only 3 rows. We cannot keep creating it manually, right? So we need to create iterations out of this. If you look at this code, I made this code dynamic, right? If I run this again and again, this will give me more and more rows. Because our start and the end indexes are dynamic, I can just keep appending it. I don't need to create each row manually now. So what I can do is, I can just take this code for appending and write it here itself. And show you the result here. So look at this, right? 2 rows got appended. I'll run it one more time and 1 more row will get appended. Look at this, right? So 4 rows have got appended. If I run 1 more time, it will be like 5 rows. So what I'm trying to do in short, I'm running iterations of it. So this is a manual iteration. I am just running this cell again and again. But to create a data frame like with 300 rows, I cannot do it manually. We need to create a function out of this. And it's a very simple way. We are going to do exactly the same thing. So let's start writing it. So I will first of all create my base row to which all the other rows will be appended. So I will use R1 here. And after my base row was created, what did I do? I was manually iterating the rows here. So let me copy this entire thing and put it in a for loop so that I don't have to do manual iterations of the code now. So for I in range, so what will be the start and the end index for my range for the iterations now? I was trying to create 300 rows. So my iterations should be from 1 to 300. So, but my first row is already created as my base row. So I will run these iterations from 2 to 301 because I want the 300th row to be included in my range. So I will take it till 301. And then I can just use all of those codes which I did earlier. And let's just call R1. So R1 will become the final data frame that we have. So this is the exact same steps that I did for manually creating the rows. So I just copied it from above and I just included one line which was for I in range 2 to 301. This was just to create an iteration of that. Let's run this. So look at this. My data frame is created and the steps are the same as the manual steps. And this became a function using a for loop, right? Look at the magic. And this beautiful data frame is created. It's exactly the way I had visualized my output to be. Look at this. Right? The only difference between this and this data frame is that we don't have index numbers here. We have index numbers here. So it's very easy to do that as well. So I used this dot columns functionality here to assign the header names here. So I can use the same thing. I can use the dot index functionality to assign the index names. So I can easily do this using a for loop. And what is the range of indexes that we want? We want it from 1 to 300, right? So 1 to 301. Why did we take 301 and not 300? Because we want 300 to be included in the range. We don't want it to be excluded. That's why. And let's rerun this. So now my data frame is created with 10 columns and 300 indexes. My data frame's shape is 300 rows and 10 columns. This is exactly what I wanted in my output to be. I'm really happy with this result. So this is the way you can create a Python data frame from a flat file which has no headers. This was my approach to solving this problem. A problem doesn't need to have only one solution. You can have many more approaches to this. So I'll be posting this text file into the description box. Download it and let me know your approach to it. I'll be more than happy to look at your approach and learn from it. So I hope you gained some knowledge from this session about how to create a data frame from a flat file which has no headers. And if you did, give this video a thumbs up, subscribe to my channel, and stay tuned for more content. Happy learning!